Okay, we're continuing with the 2008 multiple choice portion. 23, which of the following is the solution to the differential equation dy over dx equals x squared over y with the initial condition of y of 3 equals negative 2. So we take our steps to separate the variables. Y is on the left, the x is on the right. Apply power rule, so y becomes y squared over 2, x squared becomes x cubed over 3 plus c. And once we're here, I like to just go ahead and plug in my ordered pair to solve for c. And it really depends on where you solve for c. You may get a different c value than me, but in the end, it's all going to come out to be uh, um, the same particular solution. So I just like to go ahead and solve for c once I take the integral of both sides. So I'm going to replace negative 2 in for y, plug in 3 in for x, and then we can simplify. So this reduces to be 2. We get 2 equals 9 plus c, so c is equal to negative 7. I plug negative 7 into my working equation, and then I can take steps to solve for y. So multiply everything through by 2. So y squared is equal to 2/3 x squared minus 14. Take the square root of both sides. So y is equal to plus or minus square root of 2/3 x cubed minus 14. So we have two options here. We have a positive root and we have a negative square root. And the way we decide is we look at the ordered pair. Okay, which ordered pair or which particular solution will make this a true statement. So basically, anytime you see a negative value, it's always going to come out to be the negative square root. Okay, because if I plug 3 in, then it's going to come out to give me a negative 2. There's no way that this will produce a negative value because I'm always going to get a positive outside the square root. Okay, number 24. The function f is twice differentiable with ordered pair 2, 1. F prime of 2 is equal to 4 and f double prime is equal to 3. What is the value of the approximation of f of 1.9 using the line tangent to the graph at x equals 2? So what we need to do is we need to find our tangent line equation first, and then once we find our tangent line or equation of the tangent line, then we can plug in 1.9 to find the approximated y value. So our ordered pair is 2, 1. Our slope, they tell us, is 4. So we have our ordered pair, we have our slope, so we create our equation. So y minus 1 equals 4 times x minus 2. And now I'm just going to replace x with 1.9. And 1.9 minus 2 will give me a negative 0.1. So this gives me negative 0.4 plus 1, which is 0.6. Or 1 minus 0.4 is 0.6. Okay, 25. Let f be the function defined above. So here is our function. We have a piecewise function where c and d are constants. If f is differentiable at x equals 2, what is the value of c plus d? Now, if a piecewise function is differentiable, then there's a number of things that we can do. Differentiable assumes that it's continuous, so that means we know that there can't be a break between these two branches. So we can just set these equal to each other and replace x with 2. Also, we know that it's differentiable, so that means that their slopes must agree at 2. It has to be a smooth curve, so at x equals 2, these branches must share the same slope. Otherwise, you're not going to get a smooth curve. So what that means is we can also set their derivatives equal to each other. So our function is continuous at 2, and our function is also differentiable at x equals 2. We can set their equations equal to each other. We can find their derivatives and also set them equal to each other. And then we're going to have a system of equation that we can use to kind of help us solve for our missing variables. Okay, so first off, I'm going to set their equations equal to each other. We know that they must meet at x equals 2, so I can replace all the x values with 2. So I get 2c plus d is equal to 4 minus 2c. And I can solve for d, which is negative 4. Okay, and also, so this is nice. I already have the d value. I just need to find the c value. So I can set their derivatives equal to each other. So the derivative of cx plus d is just going to be c, and then d is remember c and d are constants, so the derivative of a constant times a variable is just going to be that constant, and d will just go to 0. The derivative of x squared minus cx will be 2x minus c, so I can set them equal to each other, solve for 2c is equal to 2x, and I know that x is equal to 2, so I replace 2 in for x, solve for c, I get c equals 2, so therefore c plus d must be 2 minus 4, which is negative 2. Okay, 26. What is the slope of the line tangent to the curve of y is equal to arc tangent of 4x? So at the point where x is equal to 1/4, so I need to find the derivative of arc tangent of 4x and then find its derivative. So evaluate the derivative at this point. So first off, let's find the derivative of arc tangent of u, which the rule is u prime over 1 plus u squared. And if we match this up, simply 4 over 1 plus 4x squared. And this reduces to be 4 over 1 plus 16x squared. We have our derivative. Now we can plug in our x value. So 4 over 1 plus 16 times 1/4 squared. And this reduces to be 16 over 16, which is 1. So 1 plus 1 is 2. And 4 over 2 will give us 2. Okay, 27. Shown above is a slope field for which of the following differential equations. And we know that the way that we can match up the slope field is we can identify slopes that are easy to determine. So here I see a slope of 0. So that means that if I plug in 0 in for y, this is where y is equal to 0, right? Then I must get a slope. I must get a slope of 0 because I'm getting all these as horizontal lines. Okay, and also another easy slope is where x is equal to -1. So basically, whenever x is equal to -1, then my derivative, my dy over dx, must be always equal to 0 because I see that's the case here. And so the only one that's going to work will be the xy plus y. All right. If y is 0, then I'm going to get 0 plus 0. When x is equal to -1, then I'm going to get negative y plus y, which is always 0. And if we try to match it up with any of these other options, we're going to see that the only one that is consistently true for both of these sets of slope is going to be c. And usually what you want to do is you want to pick out where slope is equal to 0 and go from there, because those are the easiest ones to determine. The ones where you have slope that are positive or negative, you can make some guesstimations, but it's going to take a little bit longer to evaluate. So where slope of 0 is going to be the easiest for you to get a solution. Okay, finally 28. We have our differentiable function where f of 3 is equal to 15, f of 6 is equal to 3, f prime of 3 is -8, and f prime of 6 is equal to -2. And we're told that our functions g of x and f of x are inverses of each other. So what we can do is I like to make a table here with f of x on one side and g of x on the other. We know that their order pairs must be reciprocals of each other. So if g of 3 is equal to 6, then f of 6 is equal to 3, right? That is the property for functions that are inverses of each other. We also know that at those corresponding points, their slopes are going to be reciprocals of each other. So that means f prime of 6 is equal to -2, which means g prime of 3 must equal to the reciprocal of -2, which is -1/2. So therefore, g prime of 3 is equal to -1/2.